Good morning, everyone. I'm Jafar Sadiq Ali, working as a professor in Department of Triple E of Sri the Government Institute of Technology, Chennai. I'm handling subject of IoT concept applications, and today in the Unit 4, we are going to see the topic accessing GPIO pins, sending and receiving signals using GPIO pins. Let's move into that. Let us first see the expansion of GPIO pins. What is GPIO pin stands for? General Purpose Input Output. So this is the input to receive the input as well as to make the output. These are the pins generally available. That's the main thing is GPIO. So these pins allow Arduino or any controller to communicate with the external devices, either to accept input or to generate output. So GPIO pins can act as a input pins means receive signals from either sensors or switches and push buttons. Output pins is meant for sending signals to LED to glow or the motors to run and the buzzers to make sound and the relays to operate. So these are the main purpose of GPIO pins. Interacting with the external world by accepting through input pins some commands and also generating or sending signals through the output pins. So this is the importance of in IoT. Why it's important means this forms the basics of sensing and controlling applications automatically, and it's connecting the physical world with the IoT systems. Okay, now move on to the next one. Sending signals using GP. We now seen what is GPIO and what is the input output and why it is important. And now we are going to see GPIO signals using G out as output mode or input mode, whichever is you are okay with that. We just move on with it. Okay, now first we go with the input mode. GPIO as input. Purpose is Arduino receives the signals from sensors and switches. How it works? We have to configure the Arduino IDE programming platform. We need to configure pin number as input. See the letter caps in caps INPUT and read either high or low signal. See the high is a capital word, low is a capital word, and process the received data. Whatever is we have received, we have to receive the data. Example is push button input. Okay. Applications, motion detections, door sensors, push button controls, and environmental monitoring. So these are the main applications of the inputs. See the in the right side we see the programming part. See int integer button pin equal to 2, which means the second pin we are assigning as a variable button pin, and that button pin now we see last class we have seen how the IDE have the programming has a structure, setup structure, loop structure. Setup is the going only one time is going to run and loop is going to run again. See here void setup programming inside the pin mode. Pin mode. So here we are going to configure the pin. Pin mode. What pin? That button pin. Button pin as what? Comma input. Input is see the input is the calculator. So button pin, whatever is connected in the number two, it is going to accept the real-time values from the physical world. And void loop is integer state equal to digital read of button pin. So whatever we receive, we need to able to read. The microcontroller has to read. So that's why we have a digital read one function in bracket button pin. So button pin, whatever input comes, we are going to read out. So this is a one classic example of how the GPIO pin is act as a input mode. Now we are going to see how it is acting as an output mode. See here, purposes are Arduino sends electrical signals to control external devices. How it works? Configure any pin as output. See, capital letter output, and write high. See high charge is a capital letter word. High 5 volt or 3.3 volt. We cannot give us a 5 volt 3.3 volt, just high only, or low. Low means zero voltage, no voltage. Connected device responds accordingly. So if you make it now, then connected device based on the voltage supply given means motor will run. Supply given means buzzer will make a sound. If no supply given means LED will glow. If no supply, if low means 0 volt means nothing will happen. So based on the signals, the counter device will respond accordingly. Examples: LED control. See the right hand side programming. INT LED pin 13. So 13 is the pin, is the LED pin. And see void setup. Void setup one time only going to run. Pin mode. Pin mode is LED pin 13th pin number is going to act as a output mode. It's going to generate electrical signals and give it to the outside world. And void loop is the n number of times we are going to execute. Digital write. I'm going to write digitally LED pin to be high. High means 5 volt or 3.3 volt. Which means I'm going to supply to the, and delay. Delay program is nothing but now some gap has to be given. 1000 means 1000 millisecond, 1 second. Again, digital write. LED pin, comma, low. Low means no voltage, zero voltage. So LED will be off. Again, delay of 1000 milliseconds. That means 1 seconds. So this will keep on running means LED will be going high, low, on, off, on, off. That's it. So thus we have seen GPU IO pins now act as a output. So input and output we have seen, and this is the typical 3.3 volt, 5 volt ground we have seen, and sensor input act as a input mode, sensor output is going to act as a output mode. And finally, the advantage and applications is simple and easy to understand, and programming also is very easy. It's a very low power consumption device, compatible with the main number of sensors and actuators. It enables both input and output operations as well as real-time device control. And application is, as we have known, with n number of applications. We have smart home, smart agriculture, smart street lighting, smart healthcare, industrial monitoring also. We can make use of this. With this, we conclude the sessions. Thank you.